So hello and welcome, dear visitors of my channel. Today we're going to continue with the new sets of video, and the reason is because I have a new course where we decided that we need some advanced knowledge of people. And if you remember, in the last video we made the regression analysis and made the ANOVA analysis of the data that we had at hand. We're going to make some assumptions which are not completely correct, but we will work with them. First, we're going to use the old data set, which is wrong. I will explain in a second why. And then we're trying to run confirmatory factor analysis in AMOS, and then we're going to run a structure equation model. So what is wrong with this approach? If you want to make confirmatory factor analysis, we usually collect a new set of data. And the reason is simple. Let's assume you use the scale that is new completely, you developed it on your own, or you decided to change the scale. In this event, we run first exploratory factor analysis to see how many factors SPSS will find in it, and we will then know whether the model is good or whether the data collection tool that we developed is good or bad. Then we need to run again the study. Previously, the journals used to accept exploratory and confirmatory factor analysis with one study, and we have recently published a study where we had only one data collection and where we ran both exploratory and confirmatory factor analysis. We explained that we cannot collect a second data set for administrative reasons, and that the new data set or new data tool that we developed was actually based on existing ones. That's why we can assume that confirmatory factor analysis can be run with the same data. But usually it doesn't work. So what we have, I'm going to take the same data that we finished our study with, which was this data set. In our event, it's YEB 2025 final. You can find the link in the description to this video below. In one of the previous videos, I think in all of the previous videos, I had these files. And we are now going to assume it is a new data set. And we assume that we run the confirmatory factor analysis with the data set. The second assumption that is wrong in this event, we're going to build a structural model based on the variables that we have here. This is behavioral inhibition, behavioral activation scale. It doesn't really make sense because these items are related, they belong to one category of items, and if you usually run structure equation model, you have different independent variables. You want to connect them in a very complex way. We assume that maybe behavioral inhibition has impact on behavioral activation, that has impact on behavioral activation scale D, that has impact on behavioral activation scale F. So this is the model we're going to build, which doesn't really make sense from the point of view of theory, but we just want to train, and I just want to show how you run this model. In this first video, we're going to take care of the confirmatory factor analysis and to see what we can do with the data. I would like to remind you that this data set has been generated. It is generated data set. It means for those who are my students, you will have your own data sets. For those who work with their data, it may look a bit differently. That's why don't be afraid. We're just going to do as if it is correct, as if it is the newly collected data set by real people, but actually it is generated. So knowing this, what do we have to do? First of all, we need AMOS. There are two structure equation tools that I know. There are more, but two with which I work, which is AMOS from IBM, the same as SPSS. Usually it comes as a bundle, SPSS plus AMOS. We also have SmartPLS. SmartPLS has different assumptions than AMOS. AMOS is the covariance-based tool. It looks at the covariances of all items that you have in your model. It means all the items, it means each question and response to a question is a separate item. It will look at all the covariances. So if you had a problem with developing a theory or doing something and you are wrong, the system will notice it. It will show you they have issues with the model fit or you have other issues. In the event of SmartPLS, it will not be the case. SmartPLS is theory-driven. If you assume that A has impact on B and B has impact on C, SmartPLS will just take the assumption. It will look at variance, but not on covariances, at covariances. In this event, if you made a theoretical mistake, the system will not notice it. And this is the reason why many journals do not like SmartPLS. But we have more and more journals who are aware of this one, and they are more popular now. SmartPLS is becoming more and more popular. So in this event, we work with AMOS, which is more classical tool. You have fewer of problems, but you also have fewer of opportunities. For instance, in the event of SmartPLS, you can test formative factors, and with AMOS, it is impossible. You can work only with reflective factors, at least to the best of my knowledge. So we have our data set, and we're now going to do the following. I opened Amos, and Amos is a terrible tool because it has a lot of mistakes, it has a lot of issues. If you make something wrong, a mistake, the mistake will pop up with a very funny comment that you will not be able to understand what exactly was the mistake and why is this mistake there. I'm just going to show you how you avoid the mistakes, and I'm going to leave you some comments where a mistake could appear. First, we have the new model, and we need to create our items. We need to create our constructs. We have, at the moment, 4 constructs. We have BIS construct, we have bus RR, bus B, and bus FF constructs. These are the constructs we're going to create right now. So let's look one more time at the data. We have BIS has 7 items, BISR has 5 items, BISD 4 items, and BISF has 4 items. We do now the following. We go here and we start, first of all, data set. We need to say what kind of data it should be working with. We click on file name and we define where the data is located. I'm going to my folder, CFA YouTube. Here, one thing that I can recommend you, if you have the folder, create a subfolder Amos, and within this subfolder, create the subfolder data and save the data there. The reason is simple. Amos is going to create a bunch of different files, and it will create them in the subordinated folders. It means you will have, if you have it on desktop, it will create a bunch of data on your desktop. They will be not in the folder. That's why I create a folder within a folder within a folder, and then the final one start working. I'm going to open our data set. It has 167 entries there. Click on OK. And then we're going to create the constructs. The first one is BIS. It has 7 items. Just click 7 times. So 7 pieces. Then we have the next construct. We click, it will be BIS RR. It has 5, I think 5. Then we have the BISD with 4, and we have the BISFF with also 4. Then click on rotation tool and let's rotate them. Do they look a bit nicer? Then click on this item here, which is called preserve symmetries. If you don't click, I'll show you in a second what will happen. So if I click on it, it works like this. If I don't click on it, it will move only one part of this construct. We don't want to have it, we want to move it all completely. So we move it here, then we move this one here, and we move this one here. At least it should look more or less nice and allow us to see all the data that we have and make it a bit nicer. Now unclick moving item, and now let's call the constructs. For the analysis, they will need to have at least 3 letters and no numbers. This will be one of the restrictions of the tool that we're going to work with. The first one was BIS, and then we had BISRR, then we had the BISD, and then we had the BISFF. So look at the following. Each time you create a construct, it means it is a reflective construct. It is second order construct. It is BIS scale with all the items that measured BIS scale. At least one of the lines that you had here should have a parameter which is 1. Amos is going to set this parameter automatically. And now we need to fill these empty constructs with data. You click on this nice field, and we go to BIS1 and move it here. And then we go to BIS2 and move it here. So it's a lot of stupid work, but we'll have to do it because otherwise it will not work. As I told you, this tool is very outdated, very old. There are updates, but actually they are not doing anything useful, and most cases you just need to do a lot of things manually. And if you try to run the model now, you will get a mistake, the error, and the reason is that we haven't saved the model yet, but we'll do it in a second. Now RR, you have to click on it 2 times for some reason. You go here with the second item, with the third item, with the fourth item, and so on. It will take a while, but I don't know how to make it quicker. Maybe you'll find a way. Leave it in the comments if you have it, and I don't know why, but it doesn't want to move. This to number 2. Oh, item number 2, item number 3, item number 4. and we have the SFF will be item number 1, item number you see it's not the best tool to work with, but anyway, we'll just continue and move this one here. So now it looks terrible. What we need to do, we go to view, we go to interface properties, and we go on here, display variable labels. We untick it, we'll have variable names, and this will make it look a bit better. So as you see, it became a bit better. Let's move the items in a way that we can see what is where. You can resize them if you want. In my event, you have to resize them each manually, so it is not so good. You see now the circles that have no names. These are the error terms, because theoretically we have to look at it as a regression. You will have your variable that is included, and it is a kind of, you are regressing on this variable. Reflective means it's depending on this construct, and it should have an error term. You can name them all manually, which will be very painful, but luckily they have the plugin here, and we can name unobserved variables. If I click now and run the model, a mistake will appear, just because I haven't saved it. So we need to save it. We go to File, Save As, and we need to create a name. So as you see, I already have several names because I worked with the data before. I'm going to create a new name, which will be 001, and this is the initial model. And now theoretically we have the items here, and we are ready to go through the first analysis, first confirmatory factor analysis. What we do in the event of confirmatory factor analysis, we need to see that we have no issues with conversion, discriminant validity, and reliability. Of course, you run alpha tests and so on. You run alpha tests in SPSS. I showed it in previous videos how you do it. But we also want to have some statistics regarding the discriminant validity and convergent validity. So we have to make all these connections to all the items. So we need to correlate all second order constructs with each other. So they all should be correlated. And then we have here a nice magic wand, so we can make it look a bit better. And now the model is ready to be run. Here we go to analyzing properties, and in analyzing properties we have here estimates, means, and intercepts. You click this box if you have missing data. We don't have missing data, so we don't need to click it. If you click on it, not all tests can be run. Some tests will not work, but in this event it's good. We're good to go. In the output, you click on standardized estimates, squared multiple correlations, covariances and correlations estimates, and click also on modification indices. I'll show you later in the next video why we need this one. And we don't need anything else, so all is good. Saving this model, and now we can run this model and see where the magic happens. Magic happened. You see we have now the new tab here, view the output path diagram. We will not view it, we'll just click on the results table, view the text, and here is the results table. So we need now to know whether the model ran. First of all, it ran, it shows that everything worked. Then we go to model fit, and this data will tell us whether our model is good. So this is the first step in the confirmatory factor analysis to know that the model is good. We'll need several indicators. I'm not familiar with all of them, but I'm going to show you some of them. First of all is chi-square through degrees of freedom. This is that number. And it should be lower than 3 if it is a very good model, lower than 7 if it is a good model, lower than 10 if it is moderate model, and if it is higher than 10, then something is wrong with your model. As you see, we have perfect model, probably lies on the fact that the data was generated. It is the p-value for the model is higher than 0.05, which is a good indicator. And then we have the GFI, AGFI, goodness of fit indicator, adjusted goodness of fit indicator, CFI, TLI levels, and REMC. These are those what I look at and p-close. If you want to know the cutoff values, we have the nice tool by James Gaskin. This is from whom I learned how to apply this method. That's why if you are not sure what to do, watch his videos. He explains it much better and he shows many more details, and he's much better in statistics than I am. That's why if you want to know more, just look there. And if you go to his website, which is statwiki.gaskination.com, and go to CFA Confirmatory Factor Analysis, you will see that he has already some metrics. What is chi-square value? What is good? What is I said lower than 7, you see he says lower than 5. And also you can find out what is the reference for this cutoff values. If you found something, you need a reference, why is it good? P-value, we are good to go. CFI should be higher than 0.95, or at least CFI is actually too good. GFI is not as good, 9.5, we have 9.2, but it is still traditional. And then you can look at others. We're good with AGFI, SRMR, we didn't have it, RAMC lower than 0.5. It's perfect RAMC, but it is because of data. I'll show you how it will become worse, and P-close value is also just perfect. What you see, we don't have the SRMR index, and you would like to know where we can find one. Actually, we find it in Amos. We go to plugins, and here we can click standardize RMR. You will get additional window. And if you run the model now, this SRMR index will be calculated separately. You see it's 0.485, and the cutoff value is 0.09. So we're just very, very good. And now, after we have it, we can look at several things. First of all, model fit. As you see, model fit is good. Then we go to estimates, and we'll look at the loadings. How are the loadings? You go to scalars, you go to standardized regression weights, and these are the weights. We had them also in our exploratory factor analysis. Here they will be different, for a reason that we ran exploratory factor analysis with the principal component analysis behind it, and Amos is using maximum likelihood method. You can, by the way, do also maximum likelihood in SPSS. This will make the results very comparable between the two. I usually make both and report both tables, the PCA and maximum likelihood. They have the different logic behind them, but you can find out more if you want to read on the website by James Gaskin. So what we have here is actually the loadings, and they should be higher than 0.6 and recommended actually higher than 0.65 or 0.7. And you see some items are, this one is actually pretty low, this one is lower than 6.5, so it's okay, but can be deleted. What we do next is we go to the website by James Gaskin, and we download this Excel start tools with the right mouse click, save as object, and then, because the usual tool will not be saved because it's a macros file, and your browser will block it, so you need to say yes please save and yes please allow. And then you will have the file like this. It is the old one, so if I click now, we have a mistake, and this mistake pops up just because I have the German Excel and it is made for American or English Excel, so will not work. So we just close it, and we have to open it one more time. Don't save. And here we go. I just have the file that I have recently downloaded. And in this file, we go to validity master, and we want to investigate our discriminant convergent validity. And here it says you have to paste correlations table here and standardized regression weights over here. And we find correlation matrix here, copy, here paste, and standardized regression weights, table copy, and here we click on paste. Click on calculate, and you see we are actually good to go. We have two indicators that are marked red. This is the average variance extracted, AVE. It should be higher than 0.5, which is a very conservative measure. According to Diamantopoulos and Sigwo, I think in 2005, if I remember it correctly, they wrote a paper that actually higher than 0.4 is good, and we're on the edge of 0.5, so actually it is okay. But in the next video, I'm going to show you how we can improve this data a little bit. And this is the table that you can copy and paste in your work and already show that you have composite reliability, which is almost very close to Cronbus alpha. Bit more conservative way to calculate Cronbus reliability or internal consistency of the items, and composite reliability is especially good if you have items with a different measurement types, let's say Likert scale 5 and Likert scale 100 and Likert scale 7. So usually recommend in this event to calculate composite reliability. Average variance extracted, maximum shared variance, it means how much they share with each other. As you see, it is very low. The MSV should be lower than AVE. It means they should measure what they have to measure and should not measure what they don't have to measure. As you see, they are not measuring what they don't have to measure, and they measure a lot of what they have to measure. This is maximum reliability H coefficient, which should be higher than, I think, 0.7, which is also very good. And we have the cross-correlation table, and these bold items, these are the average factor loadings. As you see, everything is perfect, and the average factor loading should be higher than average forensic structure, I think, so we're good to go. This table, this tool will mark a threat if you have issues. As you see here, minor issue, but we're going to correct them in the next video. So for now, we have this table that shows that our tool is not bad. In the next video, I'm going to show you how we can improve it even further. See you in the next video.